Okay, we've talked about horizontal and vertical asymptotes. Now we're going to talk about horizontal and vertical tangent lines. So you're going to be able to determine at what particular point some function is going to have either a horizontal or a vertical tangent line. Remember, tangent lines are where the graphs and a straight line intersect in one spot. Let me just remind you up here. Let me just draw a function. Okay? So let's take a look at this. Here's an example of what I'm talking about. So a horizontal tangent line. So if I were to draw a tangent line right here, my tangent line is going to hit this graph, this function, right about here. Okay, well, what's the shape of that tangent line? That horizontal tangent line? It's horizontal, which means the slope of the tangent line would be 0. Okay, well, how do I get these tangent lines? Well, in order for my slope to be 0, remember slope would be 0 over some number. That means that my numerator must be 0. Vertical tangent lines will have a slope that's undefined. And in order to get an undefined slope, I would have some number here, and I would have 0 here. So your denominator is going to equal 0. So it says here, determine the points, if any, at which the function would have a horizontal and or a vertical tangent line. Well, we're treating this like a non-calculator problem, so you can't use a calculator to look at the graph like we did the previous slide. So what you're going to need to do is you're going to figure, first, these are your thought processes. Okay? It's asking for tangent. As soon as you think tangent line, you should be thinking, ooh, slope. Slope means derivative. So what do I need to do? I need to figure out the derivative. So y is actually equal to x to the negative third. These are identical functions. And now I'm going to figure out the derivative. So y prime, I'm going to use the power rule. I'm going to subtract an exponent. And then I'm going to simplify. Here's my derivative. Take a look at this. Okay? When will the numerator equal 0? When will the denominator equal 0? Those are the questions. Will this numerator ever equal 0? Can I ever make negative 3 0? No. So there will be no horizontal tangent lines. Okay? Will my denominator ever equal 0? Sure. When x equals 0. So at this point I would say I'm going to have a vertical tangent line at x equals 0. Determine the points, if any. So now I need to figure out what the y value is here. The x value is 0, so there's going to be a vertical tangent line at the point 0, comma. So what I'm going to do now is I'm going to plug this into this original problem. And I'm going to write 1 over 0 cubed, which is just 1 over 0, which, oh, wait a second, that's not possible. So according to the math, we should have had a vertical tangent line at x equals 0 as a possibility. But then when we plugged this point in, we realized that you can't even have anything at 0 in the first place. So we attempted it. Now we're going to cross that off, and we're going to say that there are no horizontal tangent lines and no vertical tangent lines. Horizontal tangent lines was definitely a no-no here because there's no way we can make the numerator 0. We thought we had a vertical tangent line, but since it was impossible to have a point in the first place there, being 0 comma anything, I had to scratch my mindset and say, okay, now I don't have a vertical tangent line either. Let's do the same thing here. I'm asking for all horizontal tangent lines and vertical tangent lines. So first off, I need to figure out the derivative. Derivative of x, 1, minus. The derivative of cosine is negative sine. So now notice here that my real derivative is 1 plus sine x. So let's take a look at that. And ask yourself these questions. When will my numerator be 0? When will my denominator equal 0? Well, scratch that since there is no denominator. So I have no vertical tangent lines. But could my numerator at some point be 0? Well, this whole thing is my numerator, so let's try it. Start solving for x. I'm going to subtract 1 from both sides. Then you want to ask yourself, where on the unit circle is your sine value negative 1? Remember that sine is your y value. So where is it? It's down here. Okay, what is this angle? This angle is 270 degrees, but what is it in radians? We only deal with radians. Remember that's 0, half pi, 1 pi, 3 halves pi. So when x is 3 halves pi. Possibility. We don't know for sure if it's going to work. Just like the last problem, what I'm going to have to do is I'm going to have to plug this into the original problem wherever there's an x. Okay, so what's the cosine? Let's do this. What's the cosine at 3 pi over 2? Well, that is this number right there. So this whole thing is just 0. So the original question from the previous slide said, determine the points, if any, at which we have horizontal and or vertical tangent lines. We established that there was no vertical tangent lines, but there is a horizontal tangent line at the point x value, y value. I'll give you a minute to take all that in.